Hi everyone, before we show you the second part of our video today, I wanted to take a brief moment to explain what we're trying to demonstrate. In the 90s I was professionally cleaning carpets and upholstery for a living, and I had multiple extraction machines, and these machines were adequate and I was achieving the desired results. Where I became frustrated was when I was going on to very severely soiled carpets, for example in a restaurant or a pub that had been fitted with a very heavy quality commercial wool carpet. Once I'd applied my pre-sprays, agitated, encapsulated and suspended the soil in the carpet, when I went to rinse this out, I found in these scenarios I may have to do 3-4 passes with the wand rinsing before I could get all the soil out of the carpet. If I increased my jet sizes to create more flow, in theory that should have worked, but by doing this my pressure dropped off because there was more flow and I didn't achieve the extra flows that I wanted. If I decreased my jet sizes, I could create far higher back pressures, but unfortunately because I decreased my jet sizes, I now again had less flow at the tool end. Hopefully this second video will demonstrate what I'm trying to say. Thank you for watching. Good morning and welcome back. Today we're going to run a second part of our test comparing a digitally controlled low pressure portable extraction machine with a high pressure portable extraction machine. We had some very positive feedback from our first video, and we were also asked quite a few questions, and the main ones being what would happen if we ran the same test but we increased the flow by enlarging the jets, and the one that we got asked most of all was what about if we reduced the jets and restricted the flow, how would the machines perform then? So what we're going to do today is we're going to do exactly that. Whereas we ran 2 O3 jets on a wand on the first test, we're now going to reduce those to O2 jets. So what we have here now, we have the original wand with O3s. We've now fitted this wand with 110 fan spray tips and O2 jets. So by reducing down from O3 jets to O2 jets, we've now reduced the potential flow that the pump can get through those jets by 33%. So the first thing I'm going to do is I'm going to couple up the digitally controlled machine, and we're going to fire it up, and we're going to see on the gauge exactly what pressures we're going to get at the tool end. Because it's digitally controlled, I'm not expecting any difference, I'm expecting it to adjust. So if I put the machine back on, we're still set on the high setting, which we ran the first test on, and as I said in the first test, we calibrated this at 100 psi for these test purposes. So I'm now going to pull the trigger on the wand. And as you can see from the gauge, we're gaining a little bit more back pressure. The digital control system is taking over and is compensated to ensure that we still get the same amount of flow at the tool end out of the wand, but that we don't lose any performance. Now we'll run exactly the same test on the high pressure machine. Now the wand is shut at the moment, so again we'll switch this machine on. And again the pump's creating 350 psi, but there's no flow, so this is just pure back pressure on the pump, and then it'll start recycling in the head. So as I pull the trigger on the wand, as you can see from the gauge on the wall, we're rating just below 120 psi. So we'll switch this machine off now. Now as you can see from our second test, because we've restricted the jets in the wand to O2s, as I said at the beginning, we've reduced the flow by 33%, so we've lost a third of our potential flow out of the jets onto the carpet. With the high pressure machine, although it can build up the 350 psi back pressures, as soon as it's allowed to open flow, when we did the test with the O3 jets, there was enough flow there for the pump to take maximum advantage of how much it could deliver as specified by the manufacturer. And it was delivering its maximum flow via 84 psi of pressure behind the jets. When we put the O2 jets on, we've restricted the flow, as I said, by a third, and the pumps created a lot more back pressure. We can't see any benefit to this at all, because we might have increased our pressure behind the jet, back pressure, to just below 120, but we have to take into account we've now reduced our flow by a third. So we've got higher pressure, but far less flow onto the carpet. So if I put this tool back over here, what I'm going to do now is I'm going to connect a hard floor wand up, and the hard floor wand, we're going to go totally the opposite way. This hard floor wand has 4 jets fitted to it. The jets are again 110 fan spray tips, and all 4 of these jets are 02s. So if we make a comparison with this tool, the O2 jets on this wand, there's 2 of them, we've now got 4 on this one, so we've got 50% more flow over the tool that we've just run. And if we compare that with the original test with O3 jets, we've got 25% more flow on this. So I would expect with the high pressure machine that was delivering 84 psi to achieve maximum flow through the jets with O3s, now that we've increased the flow by 25%, it can still free flow, and I wouldn't expect much of a difference. I would still be expecting around the 80s back pressure to achieve maximum flow. So what we'll do first, we've got the machine still coupled up to the high pressure machine. I'm going to fire this up, and we're actually going to see exactly what we can deliver with far higher flows. So I'm now going to open the wand up. And as you can see on the test rig, we're achieving the same results that we have with the O3 jets, because the pump had already delivered the maximum flow it could. So by increasing by another 25%, it is still using the same amount of pressure, and the pump head's maxed out. So what I'm going to do now is I'm going to go to the door, and we're going to actually see what this wand is delivering outside these jets. We've seen the pressure. So with 4 O2 jets at just over 80 psi, now you can see the solution that's coming out of these 4 jets. So as you can see from this demonstration, the 4 O2 jets are allowing maximum flow. The pump can only deliver what the manufacturers specify the pumps can do. So for instance, our digital flow control machine, the pump is manufactured, the flow is balanced with the pressure, and in its best scenario, it can deliver 6 litres of water per minute. What I'm going to do now is I'm going to run this tool on the digitally flow controlled machine, and we'll see how the digital control system performs. I'll just depressurise the rig. So we've now connected the 4-jet wand to the digital controlled machine with a lower pressure pump. I'm going to switch the pump back onto its high setting, and I'm now going to open the trigger. So you now can see that the digital control system's taken over. We've increased the flow substantially, so the machine is adapted to ensure that we get the correct pressures at the tool end. So again, what I'm going to do is I'm going to take this one outside and let's see what we're delivering. We were actually creating just short of 110 psi, so we should be getting far more flow over the 80 psi that the higher pressure pump was delivering. So now you can see the difference in the flow coming out of those 402 jets. So we'll switch the digital control system off. So what we were trying to demonstrate with this is that although we have a pump that can create far higher back pressures, because it hasn't got any control systems, it'll give the maximum it can give on its flow if it's allowed to via the jet sizes. But once we start restricting and so on, we have no control over it. With the digital flow control system, we've just demonstrated that because of the adaptability of it, we've just delivered far higher pressures, although we've increased the flow substantially, so we're getting far better flows onto the carpet. What I'm going to do now is, this pump can deliver 6 litres a minute, but we've actually capped it. So I'm going to go into the programming on this machine, and I'm going to demonstrate what a variable speed control system can do, because this pump still has a lot more in it. We still haven't taken it to its top tolerance of which this pump will deliver. So we're going to see how high we can go with this 160 psi pump with a 6 litre delivery, and see how much we can get out of it without any restricted flows at all in 402 jets. So what I'm going to do is I'm going to hand the tool now to John, and John, if you want to give Hugh the camera, if you could take this tool please, and what I'll do is I'll go into the programming mode on our machine. And John is actually going to open the flow on the 4-jet wand once it's in programming mode, and I'm actually going to, through the control system, increase the pressures and see exactly what we can achieve. So I've now gone into programming mode onto my machine. I'm going to switch the pump on. So if we can go back to John please, Hugh. Now at the moment, we're running the tool on the digital control system at 100 psi. I'm now going to, because I know this pump can achieve a lot more, increase the digital control system and tell it I'd like a lot more pressure. So as you can see, the flexibility of the digital control system, I'm delivering far more pressure. If I go to the gauge on the wall, as you can see, we're now delivering through the 402 jets at 140 psi. If we go back to the tool again, if you want to switch off, John, and back on again. You can see from this demonstration, thank you John, you can see from this demonstration that if you have total control over your pump's flow and the pressure, and it can create the correct pressures to deliver the flows, we can get far more pressure at the tool end and far more flow onto the carpet with a 160 psi pump and 6 litre flow, because we're controlling it. Whereas with no controls, all we can do is shut the bypass down and do the pump, let the pump do the maximum it can. It creates massive back pressures, but that isn't actually flow onto the carpet. Thank you for watching.